Hello everyone, Mike with Spray Jones coming to you with another video. This one we're going to get into the fire code and spray foam insulation. Now it's a huge subject. It could warrant multiple videos on its own. I really don't want to go that route. Instead, what I want to do is, rather than do an exhaustive explanation about the fire code, I just want to show you the principles of what you're trying to look for and achieve. And then you go out and work the system for yourself, because your state, your county is going to vary massively across the continental United States, and then the provinces in Saskatchewan are more or less very similar, but even still certain regions and counties within certain provinces have different designations or different authorities having jurisdictions. So before we get into it, thank you to everybody that has subscribed and shared the videos and commented. I really appreciate it. Check out the playlists. There's probably more information that you haven't seen. And thank you for engaging with me and us. If you are putting spray polyurethane foam insulation closed cell into a structure, whether it's open cell or closed cell, you are probably in 99% of the time going to be required to cover it. Now, the reason I say 99% of the time is because there are certain exemptions. So let's just pick on closed cell medium density foam because it's the more stringent of the two, and it's going to require the most covering in the most instances. If you are going to be putting it into a wall or into a roof or into a crawl space, you're going to have to check the regulations in your area for what the code states that it needs. Most of the time in a wall and a roof, we're not leaving the spray foam exposed. It's going to be covered with drywall or tongue and groove boards or paneling or some type of interior finish. I don't know why most people would not want the spray foam covered. It's not pleasant to look at, but we'll get into that later on in the video. Open concepts are becoming more and more popular. But where you are not in habitable space, as far as you're living in the space, would be an attic or a crawl space or a concealed adjacent space. And those instances, there are exemptions where the foam is not needing to be covered. So what I'm going to do is I'm going to give you an example. I'm going to walk you through the National Building Code of Canada very lightly, very easily, so that you can see what we're talking about and sort of apply the principles and know what to look for in your build. So National Building Code is looking at the protection of foam plastics, and it states here that except as provided in sentence 2, the foam plastics which form part of the wall or the ceiling assembly in combustible construction shall be protected from adjacent spaces in the building other than the following exemptions: concealed spaces with attic or roof, crawl spaces, and wall assemblies. And then it says, by one of the interior finishes described in sections 929, or sheet metal mechanically fastened to the supporting assembly independent of the insulation and having a thickness not less than 0.38 millimeters, provided that you're meeting Group C major occupancy or any thermal barrier that meets the requirements listed in 3.15. So you'll see that the exemptions here are for attic and roof space, because these are not going to be active living spaces. They're conditioned space, but they're not living space. But then they give the listing that a crawl space is no longer deemed a crawl space if it exceeds 1.8 meters in height. So 1.8 meters is 5.9 feet. So think of it as just under 6 feet. So the crawl space needs to be under 6 feet in height, not be a plenum in combustible construction, meaning they're using it as a return air plenum to bring cold air back, or it's a return air system involved in the HVAC system, or for the passage of flue pipes. At which point, if you had these, it would be considered a basement, and it would apply under section 9.10, which means the protection of foam plastics. So we're clear. You have spray foamed the inside of your structure. If you want to do the crawl space, great. You're not required to put a protection over the foam provided it's under 6 feet in height and you don't have what I would say is mechanical equipment or hot flue gases passing through to the outside. Now, most high efficient furnaces now are not processing hot. It's not a pipe that can't be touched. Most people don't put mechanical equipment in. However, some do, and at that point we have to make changes or alterations. When we are dealing with an attic space, again, if the mechanical equipment is not within it, it doesn't matter whether it's 10, 12, 13 feet up inside that attic space, as long as there is one of the interior finishes to the interior side, compartmentalizing it and forming it, making it a crawl space or a attic space, then it's exempt, and you don't have to put the covering right directly up against the foam insulation. So what would they be looking for in this subsections of 929.4? Most people are familiar with drywall. That is going to be your most common list of material. But there's other materials that we list in the building code besides gypsum board, and those would be a plywood finish, provided that it meets a certain thickness, and they give you a chart for that. They allow hardboard finish, which would be your typical oak or pine or cedar, or some type of tongue and groove board that you've gotten your hands on. Again, there's minimum thicknesses depending on the spacing and whether it's supported and backed up. They just don't want you buying something super thin. Then they cover an insulated fiberboard finish, and finally particle board, OSB, or wafer board finish. So you're not just capped with putting the gyprock up, and then they list the ability to have some type of spray-on thermal barrier that is going to meet the requirements. So as I've stated earlier, everything listed usually in your code or our code, your code, is going to be some type of prefabricated interior finish. Wood, drywall, pine, solid boards, fiberboard, some type of interior finishing is going to be approved, even metal, depending on occupancy, for the interior finishing to cover the polyurethane foam insulation. Now, when you don't have a prefabricated product, you're going to have to go to a liquid applied product. And that's where we get into the definition of what a thermal barrier is. So take a look at this DC315 intumescent coating. The thermal barrier is a very specific set of language. What they are referring to is not a ignition barrier, just an ignition barrier. So stopping something from lighting on fire or preventing it or hindering it. Not a flame spread barrier, which means once fire is broken out, it's going to take the maximum amount of time to spread across the surface. But an actual thermal barrier, so it's doing all three. It's doing the ignition, it's doing the flame spread, and it's doing the heat, primarily heat. They want to limit the amount of heat that is making it to the surface of the foam and then be able to ignite and be able to flame spread all in one instance. So in order to do that, this isn't just going to be some simple paint, all right? We're not looking at some ultra thin little coating to go over top of it. We're looking for something that is going to provide an actual buffer or barrier between the heat source and the substrate we're trying to protect. And that's exactly what the DC 315 does. Intumescent means to intumess. Intumess means to puff up like shaving cream. So it's going to look like paint, smell a lot like stinky paint. For all intents and purposes, visually, you can't tell a thing until the flame is put to it. Once the flame is put to it, it puffs up. It forms sort of this meringue, this marshmallowy type substance on the surface of the foam, and then protects it thermally on all three instances, what I've said, for the maximum amount of time. And thereby your foam insulation is protected. So just quickly reading here, they're claiming to have achieved between the 15-minute and the 20-minute. 15 minutes is the bare minimum that you can get. In fact, a half-inch gyprock, for instance, doesn't even rate to 15. It rates to 20. So this is why you're going to see a lot of times they rate it to 15 or 20 minutes. The requirements for thermal barriers are usually going to be at 15 minutes. They want a 15-minute thermal barrier. They're just saying here that it's been approved as an alternate barrier system. It's been applied over spray foam and tested to the criteria set out, including U.S. and Canadian designations. Let's just scroll down to where more of the testing is. Code compliance for the following designations. CCMC evaluation in Canada. You can't be installing inside construction without a CCMC number. They're UL listed as a component for exterior wall systems in accordance with architectural cladding options. Third party listed and inspected. And then they offer a whole bunch of top coat colors. White, black, gray are going to be common, coming in 5-gallon pails or 55-gallon drums. Usually we're talking single coat coverage at 24 mils, so that means 24 thousandths of an inch in wet film thickness, which is not very thick at all, folks. I mean, to put it in perspective, you're looking at 2 business cards. A business card, your average cardboard business card, is usually about 10 thousandths of an inch thick, so 2 business cards thick, a little bit more. So here's a shop, and it's not a residence, so right away we're not necessarily going to be held to the 15-minute thermal barrier needing one of the approved interior finishes. You'll have to check against your code, but this would be an example of something that would be maybe in the Class C occupancy rating. So if there is a lesser occupancy rating in your state, county, and province, then check with your authority having jurisdiction, and you might be able to clad this interior side with metal. I have yet to see one of these shops on an acreage or on a farm or out in a rural setting be classified higher unless they're conducting a commercial business out of it. So it's an ag shop, it's a welding shop, it's a machine shop, and they need to have more protection. So this would be able to be horizontally strapped and then vertical metal to be placed on the inside. Likewise, if the client did not want to go and put the metal up, I would offer him one of 3 different kinds of spray-on coatings. The first would be what I call one-up from paint, just a little bit better, like an acrylic elastomeric paint to help with the UV, and it helps with a tiny little bit of sparks and ignition delay. The second coating that I usually offer people is a high-grade industrial flame spread rating. It's washable, they can pressure wash it, it can go on the roof and the walls. It can take quite a bit of impact, not a lot, but enough that if they bang into it and brush up against it, it's not going to be ruined. And it provides very high level of protection for flame spread rating to some ASTM standards. And then the third and final one is giving them the DC 315 option for the interior. But as I've said before, if I was doing the whole entire shop in spray foam and then the whole entire shop again in DC 315, it would be an incredibly large bill. They'd have the spray foam bill, and then the DC bill could in a lot of cases be equal to or greater than the spray foam bill. So you really gotta weigh these out. I mean, if there's a few select areas that need the DC, fine, then obviously the bill's going to be just a fraction. But to do a hard coat in a large area, it's going to be a lot more money. Here is an example of a hybrid system. This was going to be a berry sorting facility, food grade. So food grade panels and thermal barrier would be installed from the, I think this is the 10-foot mark. And then the remaining height, including the roof, he was planning on doing nothing. So this is a spray-on cellulose fiber called K13, and it meets the ULC requirements for thermal barrier as well. It's a fluffy product. It's a shredded newspaper. It's not a liquid applied in the sense of a paint. So this product is usually about upwards of an inch thick. So we'd go a little bit less spray foam and then go with an extra 1 inch of cellufiber. Not a bad product for acoustics, fabulous for sound, fabulous for creating a very warm and quiet environment inside the shop, but not good for smoke, soot, washing down, high humidity environments, and just dirty, dusty environments. If you're going to be doing a welding shop, they should be going with a paint-on environment. Okay, here's a metal Quonset hut that we did in 2020. You're looking at primed and 2 inches of closed cell spray foam to the inside of the arch rib building, and then 15-minute thermal barrier applied over top of it in the white. This was going to be a quasi-commercial facility since it's a bus storage facility, and the owners of it wanted it to be meeting all aspects of any occupancy, any building code, even though you probably could have made a good argument that it didn't need it. They wanted it, and it was written into their specs, so that's exactly what we gave them, was the spray-on 15-minute thermal barrier. If this was an industrial site, such as a Quonset out at a refinery or an oil and gas facility, or let's just say that this is storage for lumber mill or something like that, okay? Something that is not super critical. The people aren't working in it. They're not welding in it. They're storing facility materials, trucks. They want things to be kept warm. Then I'll check with the insurance, and I'll check with the building inspectors if there are going to be any floating around. And if I can get away with a level 2 finish and not have to give them the thermal barrier finish, I will, because it'll cut costs down. It'll still look good. It'll still function. It's still safe, and it's going to meet code. Fire codes are about asking questions, knowing what products can be used to meet it, knowing what occupancy ratings are, knowing what the authority having jurisdiction in your area is looking for, and then I would add to that a third and final group, which is the insurance companies, because insurance companies don't like to see a building like this with an inherent risk inside. So although you can be correct with meeting, there is no code in your area. Let's say you're out in West Texas, or you're out in the sticks somewhere, wherever, doesn't matter, and you say there is no code here, there's no enforcement here, fine. But what does your insurance company say? They have the right to refuse coverage on the building or contents, or a combination of both, if you have not covered up certain aspects of the construction. So I'll get my people a lot of times to check in with their insurance companies, make sure that they don't have certain clauses or designations, and then if they do, we're going to submit to them what we're doing and with what product, to make sure that they're going to be okay to sign off on it. This is a post frame shop that we did in 2014. In this situation, the interior tenant build-outs were done after the spray foam, so they put a stud wall, they put floors in, they put mezzanines in, they put demising walls. You can see over here on the left a little bit of where a demising wall is going to be, because this is the fire separation wall. And then what we did was, because they weren't going to necessarily be drywalling the ceilings in these, they were going to do an open concept. We did a spray fireproofing to the underside of the ceiling. And in this one, we did it with the cellufiber material, because it was not going to be dirty and not going to be grungy, and they wanted the sound and acoustical properties to keep the reverberation down. So the walls in these would be stud wall with gyprock on them, and that would comply. And then from there, they would have the ceilings done. Now, something that I want to say about fire code and these deep, long, vertical and horizontal cavities. There's such a thing as called fire blocking. And when in Canada, we have a code where if the insulation is greater than 1 inch away from either the exterior or the interior finishing in the wall cavity, that it's required to have a minimum height of fire blocking vertically and horizontally. Now, the posts will almost always, or will, on their spacing, make up the requirements for horizontal blocking, but you could have a vertical channel here. So if you were just going to strap this out and then put tin on the inside, you could run into an issue with a code person that there's too much depth in the cavity now, and you need to do something, at which point you would solve that by just putting in a horizontal fire block and then breaking it up. I think for us on the verticals, it's every 10 feet. So every 10 feet there has to be a piece in. With a post structure, there's enough structure in the laminate beams and columns that they don't need. They're not going to twist, so they don't have a lot of horizontal blocking other than the exterior squaring timbers. But in between, they don't have. So you might have to install that in order to be in compliance. But also, if you're putting a frame wall up, so you're putting a stud wall up inside of this, then you're good to go. I haven't seen a building code inspector reject a stud wall frame in between the timbers as not being adequate to meet some sort of requirement for fire blocking. And then just to close out, this is an agricultural private farm. This is seed storage and actual equipment storage in a massive, huge building. And we spray foamed the building over a 2-year period. Did half of it 1 year for them and then half the second year. All of this galvanizing was primed. They haven't primed the ceiling yet, but they've primed the walls here. They're putting on the 2 inches of closed cell foam. And then what they did on the inside of this building was they put a cladded metal liner to the purlins. So the purlin flange is all embedded in spray foam, but the purlin face is left clean, and then they can put the tin, like a vaulted ceiling, all the way up. So it's a really effective way to go, and because it's a lower occupancy rating, then they can perfectly do this on insurance and on code compliance for their entire facility. So you just need to ask the questions. What are you doing? What do you need to achieve? What does the code say? What does the insurance say? And then what products are we able to choose from? So there's sheet products, and then there's liquid applied products. And every year that goes by now, I find that there's another new product out on the market that can do something a little bit better than what it did before. 2014 was a real turning point when we started to get more advanced products on the market. And I expect that the codes in North America are going to change here in the next little while. I hear rumors that they're going to be rewriting some of the thermal barrier regulations to accommodate some of the new coatings that are coming out on the market, because the old standards were stringent in a certain old-fashioned way. The new products are really, really good at protecting the people, but the old standards aren't written to recognize them. So what they're going to be doing is pairing new standards and new regulations with the new products to meet the advanced technology that's out there, and that only makes sense. But it takes a little bit of time sometimes to turn the Queen Mary around in your harbor. You know, it's a big ship. It can be done. It's just going to take a little bit of time. So I've talked way too long on this, but I hope that it's been of help to you, and you can click on the like and subscribe and share, and we'll catch you later on the next video.